Hello, I'm Krzysztof, or Chris if you're English speaker. Uh, let's start with quick plan of this presentation. So first I'm going to tell you a little about me, about me learning WebGL and all the things around. Then we're going to talk about 3D in general. Then we're going to draw a triangle, the green one, yeah. And we're going to build on that and add multiple colors. Then I'm going to tell you a little bit about matrices and tell you a little bit how you can learn on your own. And I want you all to ask questions, like in between the talk. If something is unclear, then just raise your hand. Someone will probably give you a microphone. If you don't want to do that, then we should have time at the end for the questions. So let's start what you can use WebGL for. The easy answer is that you can create 3D environments, games, probably not by hand like Triangle today, but that's like the second lesson. The other thing that's more interesting to me a little bit is that data visualization. So if your canvas or SVG is too slow for rendering, then you can use WebGL. And you can draw actually 2D things in WebGL. So let's start about me. So the thing is, WebGL is just a hobby for me. So it's like I do it in a spare time. But I'm learning 3D and WebGL for like 4 years already. So when I started, there were already only OpenGL books. Then I moved to the courses, played with 3JS, a little participated in a couple of workshops. And last year, I'm reading a couple of WebGL books. And finally, something started to click in my head. And I realized that maybe you won't need 4 years to understand the same things. A little disclaimer for the people who know a lot about WebGL and 3D, that I'm more concerned about mental models, understanding how the things work, over like, is it really what's going on? Is it really how you should call it? So remember about that. And who this talk is for? It's a lot of people. So do you know why this range of numbers from -1 to 1 is relevant? Raise your hand, please. Okay, a couple of people. If you know, then I'm not sure if you can learn anything more. I won't feel offended if you leave. And there won't be any shiny demos. Like, we're going to do that and add colors, multiple colors. So if it's not interesting, like I'm not holding you here, I won't feel offended. Now is your time. OK, so let's start with Dreyfus model of skill acquisition, because Novice actually came from this model. Who heard about this model? Yeah, a bunch of people, but most of you seems to not. So quick version is that when you want to learn a new skill, whatever that is, you start as a novice, like you have no idea what you're doing. Then, well, not this. Then you're moving to advanced beginner, so basically you have some understanding, but you're dangerous. Then you're competent, so someone is paying you money for it, let's say. Then proficient is like tech leader kind of level. And the last one, and the last one, experts like Masters of Doom, Carmack style of guys. You know them. Yeah, the other thing about this is that I've seen a lot of presentations done by experts like Carmack, for example, or guys that are doing 3D for like years. And they're showing you these particles, the lightning effects. It's like, whoa. But you leave the presentation, you are really entertained, but you have no idea how to do that yourself. So let's start at this level. Like, let's start drawing the triangle. And if you're wondering, I'm probably somewhere in between competent and novice. I'm not sure where, but no one is paying me for it, so I'm not competent. And actually, I know this model for a couple of years already, but while preparing this presentation, I realized that we're actually all novices in all skills you can think of. Like, if you pick something really, really hard, and that sounds really nice, like rocket science, you can say that you're novice rocket scientist, because that's novice by definition. You have no idea what you're doing. So, dear novice WebGL programmers, let's start. So how it all works, like this 3D thing. Let's move back in time. It's like the 80s or 70s. And the universe was simpler back then. You had a processor, you had a memory, and you had like 2D array with colors for your screen. And that was basically it. But everything was super slow, and drawing things to the screen looked a lot like repeatable. So people realized that we can make hardware for it, because like making software wasn't that efficient back then. So this is how the first graphic cards came about, basically as an optimization for drawing things on the screen. But, yeah. So we end up with something like this. We have CPU with some RAM. Then we have graphic card with GPU. GPU stands for a graphic processing unit. So it's like processor for graphics, optimized for like rendering things. It has its own memory to like remember where triangles are. And it draws things to the screen at the end. Is it obvious? Everything, like, anyone has a question? No? OK. Who heard about MapReduce? OK, a couple of people. So the idea of MapReduce is similar to what happens in your graphic card right now. So your processor gives graphic card things to do, like draw this something, draw this slide on the screen. Your graphic card splits it into small chunks, like pixel by pixel, and calculates color for each of those pixels, like a separate thing. And then brings it all together to create the image you can see. OK, that's like the general model. Let's dive deeper. So the important thing at the beginning is that we need to pass some data to the graphic card. Like we need to tell, like, this is where triangle is. This is what color it should have. And it's actually important later on. The second thing that happens, if graphic card has to take your points, like the corners of the triangle, and calculate where those points are actually in the 3D space. That's the second step. After it's done, it can divide the screen into like one pixel grid and start calculating the colors of each pixel separately. And at the end, colors are joined to be one screen. OK, that's like the whole model. So where's the WebGL here? WebGL basically is on the processor side. It helps you pass data to the graphic card and helps you calculate positions and colors in the graphic card. There's a problem with WebGL. It's based on OpenGL, and it's pretty old. So it's a little clunky. And even when WebGL specification was created, some things were cleaned up a little bit. But there's still places when you have to pass false to the method for no apparent reason, just because. So copy-paste is our friend, unfortunately. And you don't have to be afraid when writing WebGL to just copy-paste the things that are just repeatable. Who heard about shaders? OK, a lot of people. And who knows what shaders are? Less people. OK, so before we know what this mysterious thing is, let's learn some vocabulary. Because 3D guys intend on not that points and pixels aren't fancy enough. So we have to use vertex for a point, or vertices. And it's just a name. Like, idea is still the same. It's like point in 3D space. This is called a vertex. And the last one is fragment. So it's not pixel, it's fragment. But the idea still holds. So I hope it's not that hard. OK, so let's focus on those boxes right in here. The thing is, your graphic card actually has like hundreds of cores. So each box in the slides is actually like small program running on one of those boxes. And the first one, first box, is a vertex shader. It's program running calculation of the position of the points, position of the corner of the triangle. And the second one is called fragment shader. It's like calculating the color. And that's basically it. So this is our shader, small programs calculating position and color on the graphic card. But there's this thing. It has to be really, really fast. So we can't use JavaScript to write shaders, unfortunately. But we don't have to use assembler as well, so it's not that hard. It's somewhere in between. It's C-like language, and the consequences are that it's statically typed, and it's compiled. So in your browser right now, you actually have the statically typed compiled language, and you probably didn't know about it. So let's see the first shader. It's like really, really dumb, so let's see how it works. It works like the C programs in general. So the little boxes in your graphic card actually starts invoking the main function. And in here, it looks for GL position. It's like the return statement of the shader. It has to pass a position of the vertex at the end of its calculation. In here, we're just setting it to the center of the universe. It's like 0, 0, 0. And 1 is there just for the math to work, so you don't have to worry about it. Is it clear? Anyone has a question? OK. So a little more practical example is that we want to pass the coordinates of the corners of the triangle from JavaScript. And to do that, we're going to use attribute. In WebGL 2, it's actually called in, like input. So we're passing the A position. That looks exactly the same as before. But we will get different values for each of those 3 boxes to draw a triangle. And the important thing is the same. We have to assign it to GL position. It's still really simple example, but this one actually works in practice, and you can draw something on the screen. So now, time for fragment shader. The idea is the same. Graphic card invokes the main function and expect GL frag color, so the color of the pixel at the end. In this case, we're setting it to full green. And this time, 1 at the end, it's like it's fully opaque. So opaque, whatever. It's like fully visible. Yeah. Anyone has a question? No. OK. So this is what we're going to get from those shaders. But it doesn't sound really nice to compile the shader every time we want to change the color to, I don't know, red or something. So let's pass color from JavaScript as well. This time, we can't use attributes, and it wouldn't really make sense, because we want like the whole triangle to be green or red or something. In this case, we're using uniform. And you can think of it like constant. It's just the same for every box, every shader we're going to run. And in this case, we're passing the color to the pixel, and the triangle would get green or red or whatever we pass from JavaScript. But I haven't shown you any JavaScript, so let's look into that now. The first thing we need to do, we need to get the canvas element, HTML tag, and get WebGL context from it. We're Actually, everyone names it GL because then, when you're invoking functions on GL objects, it looks like invoking C functions, and it's like more similar to OpenGL. That's a funny part of trivia for you. Actually, disclaimer: you don't have to like focus on the code. It's not important like what's really there, like what are actually arguments. What I'm going to show you is like highly copy-pastable. So if you find an example that works, you can just take the parts. I want you to understand what's going on, so you know like, oh, this is for it, this is for that. Okay? So the thing we have to do, first we have to create the shader and indicate that it's Vertex shader. Then we have to pass the source. So basically the source I was showing you before. And at the end, we have to compile the shader. And that's basically it. Now we have to do the same thing for the Fragment shader. And now JavaScript developers can feel like programmers because we're creating a program. After we have a program, we can attach shaders to the program, like the Vertex shader and Fragment shader, and link them together because they actually work together to draw a triangle. Okay, anyone has a question? No. So let's start with simple one. Let's pass color to the Fragment shader. The thing we need to do is we need to get uniform location from our program. And the way to do that, we have to pass as a string the uColor, the same variable name as we had in the program. Oh, not this one. Ah, over here. So that's the same name. OK. And the second thing is we need to invoke one of the magic functions, like uniform for v. Like, it's not really interesting. And you can use one of those to just pass arrays of numbers. And that's basically it. The important thing is to pass the uColor as a first argument. So it knows like where should it put that array of data. OK, so the color we pass from JavaScript will go over here for every Fragment shader that's going to be invoked. So that's the green part. What about the corners? It's actually a little more complicated because we have to indicate where those corners are. So how do we do that? First, we need to understand what's the coordinate system in WebGL. The center of your screen is actually 0, 0, 0, like center of universe. The sides of your screen, like when you're looking at your monitor, are from -1 till 1. Top and bottom are from -1 to 1. If we go to the third dimension, it's exactly the same. We can see things that are from -0 to 1, 0, to +1, 0. And it works like z-index in HTML, if you know it. Basically, the higher z-index, the closer it is to you. You just have to use floats. OK, so let's figure out where to put our triangle. Let's say these are the points we want to have for the triangle. And the first one at the top will be x, 0, y, 0.5. I think it's simple enough. And we just do the same thing for the second and for the third point. And we already know, like, this is where we want to draw the triangle. And we want to pass this to the GL position. For now, let's not concern ourselves with the 3D part of it. So the z is set to 0. But we want to have it 3 times. So we can't use uniform, because every vertex shader needs its own position. So let's start with putting it all into an array. So that's the same points. The important part here is it can be standard array in JavaScript. So who heard about typed arrays? That's basically it, the float 32. Okay, do you know which typed array to use for floats? Use this. It's basically going to work for you, especially if you're a novice. Don't worry about other ones. This is the one you want. Okay, so we have to talk about buffers. Okay, do you know what buffers are used for? Okay, one person, maybe two. Image should be a spoiler, I think. It's basically for passing data from CPU, from JavaScript, to the graphic card. So, how it works? First, we create a buffer. Then we bind buffer to this magic GL array buffer thing. It's actually important, but it's highly copy-pastable as well. So just have to remember to bind it to array buffer. And the last thing is that you have to set the data for the buffer. So we basically here passing the positions that we created just in the previous slide. Okay, so that's passing the data. Everything else is not important for you. Okay. So the same as with uniform, after we have a buffer, is that we get the attribute location. So because it was called attribute, we have to get attribute location and pass a position, because that was the variable in the shader was called. Then we have to enable vertex attribute array. So this is like the let me move back a little bit, like this array buffer, that's the thing. And the last thing, we have to set the vertex attribute pointer. And this call is really important because it tells WebGL that each corner of the triangle need to get 4 floats, 4 numbers from the array. So that, let's move a little bit, so that each row will get passed to separate vertex shader. Okay? Yeah, and this is float because these are floating point numbers. And false, I believe, is there just because. This is one example. And at the end, we have to invoke draw arrays. This is the second part because this array buffer was important. And there's this thing, GL triangles is way of drawing, and the 3 just indicates that we have 3 corners of the triangle. When you will learn WebGL on your own, there will be like different modes of drawing other than GL triangles. And for the start, like before you have any problems with that, only concern yourself with the triangles. It's the easiest one to understand. It's the easiest one to work by hand and set positions of the things. And at the end, we get the triangle. Any questions? No. You can think of questions at the end as well. So that's the thing, like the whole model. We had vertex shader, fragment shader, and at the end we have triangle. But how would we do multiple colors for the triangle? We can't use uniform. So the easy question, like the easy answer is like, let's use attribute. But unfortunate thing is that attributes are available only in the vertex shader. You can't use attributes over here. So what can we do? The fortunate thing is that we can pass some data from the vertex shader. Let's see. Yeah, from the vertex shader to the fragment shader. And it's called varring. So this is basically why we why we had to link the program and link the shaders together, because they have to work together for passing values in between. Yeah. And attributes are a way to pass data to the Vertex shader. Just a reminder. So, our Vertex shader right now would look like this. We're passing additional variable. Let's call it a color, so it's attribute color. And we're going to return varying v color. It's like return statement. And in the body of the function, we have to pass color to the alongside with the point. One thing that might help you understand what's going on over here is that attributes are like arguments to the main function. And you can imagine that the main function actually returns a map. And the GL position and vColor are like keys in this map. OK, so we want to have 3 colors. And yeah, let's start from the last one. I don't know why it's that way. OK, so the last one is blue. And then the first one will be red. And in between, it will be green. But what about the middle? I'm telling about only the corners. There's this nice thing about 3D graphics, about like this flow of graphics, that interpolates values in between. So the thing that the color is actually from 0 to 1 is pretty nice, because your graphic card can take your color and interpolate values between those zeros and ones in a pretty nice way. So we're only setting the corners, but the graphic card is actually interpolating the value of the color. So this is why it's called varying, because it's actually like, for the points in between, it's like color is also interpolated. It's like half of the every point, every corner of the triangle. OK, does it make sense? OK, so our fragment shader is actually pretty quick, pretty short. The only thing we change is that varying keyword at the front instead of uniform. And there's this thing. There's not really a good idea for writing the shaders. And because it's statically typed and you have to remember what things are yourself, people started using these prefixes like vColor, uColor, aColor, just to remember, like, to not do strange things with those. OK, so that's the result of the shader. How to pass data to this flow of the shaders. As before, we create a typed array. We call it colors. Then we create a new buffer, bind this buffer at the bottom in the third line. We're passing colors over there. Then we're getting the attribute location, the same as before, only passing the a color, because we have to pass it to the vertex shader. We're doing exactly the same thing, and we're passing, yeah, I have a typo, whatever. We're passing 4 because we had 4 numbers for each color. And we're drawing the same way. And it's basically a triangle at the end. So it's almost the end. And this is basically what I wanted to tell you, like this whole flow. And it's actually pretty useful. But let's move on to one of the hairy beasts of 3D. Who heard about matrices? Matrices. Yeah, not many people. So what this thing is for? Let's go back to 2D. What you can do with triangle? You can move it, you can rotate it, you can scale it, and you end up with 5 variables. When you go into 3D, it's not like 10 variables, it's like 20. So it's not really practical to use it. And there is actually a limit for the number of attributes you can pass to the vertex shader. It's like in the standard, it's like 8, so it's not a lot. Even then, like multiplying all those things and remember, like in which order should I multiply those things to remember like what my triangle should look like at the end, it's not really an easy thing. So I want you to think of a matrix as a black box for storing all those variables and remembering what this transformation is. And you don't really need to worry that much about math. There are some ideas from linear algebra that sound scary that will be useful. But if you're a novice and you just want to play and learn a little bit how it works, then you don't really need those. So the key is to find a nice JavaScript library that's going to help you think of the transformation and treat matrix as a black box. So the things you want to call on the matrix is like translate by these pixels and scale by this, I don't know, by 2 and things like that. And you shouldn't really worry like what numbers in this matrix mean. Like you're doing it wrong. The best thing about matrices is that if you pass a matrix to the vertex shader and you want to translate the positions, it's only one multiply. That's the best thing about matrices you can learn. OK, so the idea of this talk is that it's an introduction, and you have to learn on your own if you're interested. So what I can recommend for you. For the start, I think this book is really nice, but more like overview, so don't concern yourself if you miss something, if you don't understand something, just move on to the next thing. But read it cover to cover. The next one, it's for people who are more interested in like general 3D. The course uses 3JS. It's library for creating scenes, and there is a lot of math and explaining what numbers in this matrix mean if you're interested. But it's really great for learning, getting like general understanding and doing something practical that you can show and doesn't look like a triangle. So that's a nice thing. And the last one, I think this is the best one if you're, like me, interested in how it works from the low level. And it's actually pretty approachable, I would say. So like every chapter introduces one new idea. So if you have to pick one, this is the one I recommend. And it's actually the end. So the triangles are somewhere in those links I'm going to post, I don't know, somewhere on the internet, and are on CodePen. On Krzysztof, Kula, they're like first ones, so it shouldn't be that hard. And that's all. Thank you very much.
Good morning.